Hey everyone, welcome to the very first Sway community call of 2026. This is the very first call of this year, and we have some amazing updates for Sway to start our year with. And to share that with us, we have some amazing guests with us. Firstly, we have Igor, who is the lead of the compiler team, and another person we have is Daniel, who is like the very old contributor of the Sway. So I would like to welcome both of them. Hey guys, how are you doing?
Hi, Nazik. Fine, yeah. Always great to be on the Spec community call, definitely.
Yeah, it is always a pleasure to have you, man. And I believe it is first time for Daniel. How are you doing, man?
Yeah, everything's fine here. Thank you for inviting me. Hopefully, people will
Yeah,
like what we're going to present here.
I'm excited. Like it's awesome to have you here. And so yeah, like without further ado, I'm gonna hand over the stage to maybe Igor if you wanna get started.
Yeah, it's fine. So on my side, what I want to present now at the beginning of the year is a lot of performance improvements which we achieved over the past, let's say, few months. So as you know, like we've been developing the language primarily, like the features and so on, but always keep in our mind that we want to actually improve the output of the language and the compiler itself. And over the past 2 quarters, we actually focused on that quite some, and we have some very, very good results. So I would just like to give an overview of like in which areas we have improvements and how much. And also, like Daniel will tell us a bit more about one very, very important area in which we are improving. I'll share my screen and maybe go through a couple of things. Just for an idea, aside of improving the output of the compiler, we also improved our internal infrastructure essentially for measuring the improvements. And so as we are progressing with the performance improvements, the way we are actually analyzing it and reporting and so on will be more consistent. But now just for the overview, when I'm talking about the performance, I'm talking about two things primarily, or three things. One is, of course, the gas usage and the bytecode size, like two most relevant indicators of, let's say, how the performant the compiler's output is. And the other thing is the performance of the compiler itself, like how fast primarily it takes until it compiles the code. And so over the past couple of months, we did a lot of improvements. I went through the pull requests. It was almost 30 pull requests, varying in different kind of improvements. And if I like cluster them, they end up in several areas. One of them is storage, where we had a couple of improvements, and I will announce here there is another one, improvements in storage coming in this year, which will be a huge one, so-called dynamic storage. But just that you have an idea, so I pick up a couple of pull requests here, like optimized slot calculator for bytecode size and gas usage. What we are seeing here is this part of the new infrastructure we have, which allows us to extract improvement numbers and compare across our tests, which we use internally. And then you can see, for example, that in 9 different tests, we have improvements in this percentage, like let's say in average 9%. And then in some other tests, more tests got improved in average for 10%.
Just a moment. Sorry to cut you off. Would you mind zooming in a bit?
Yep, yeah, it's fine. It's
Yeah,
better now.
yeah,
Nice,
that's
yeah.
better. Thank you.
But just for the idea, what we are talking about is here, like in average on like 10% of our tests, in average they got reduced for 10% in bytecode size, just by improving, let's say, this slot calculator part of the storage. Then we optimized how the storage is compiled. Okay, this is now a bit, if I let me zoom out to see, let's say, to see the percentages here. Again, just for an idea, if you have a single optimization which gives you a single digit percentage improvements in the bytecode size, consider this really a lot, considering how many of these simple improvements we actually did. So storage was one part. Another one, a very, very important part, was everything related to calling functions, essentially, like the way how we pass arguments to functions and the way how we get it back. On this particular one, mem copy propagation pass, whatever it is a bit of a compiler lingo, but the important thing is this was one of the major things we did. If you see these parts here, essentially, this means like literally copying things in memory, which we in the improved version completely removed. So you will not see them here. This PR part of the code is much leaner, and the mem copies are removed. This had a huge impact on the overall code base. There were a couple of other improvements around calling functions and returning from functions. This one is also nice, like when demoting aggregate returns. Again, a lot of like low-level compiler lingo, but I think what's important for the developers is this, for example, bytecode size on a concrete project went down for 1 kilobyte just as a result of this one single optimization. And as said, we had several of them in this area. By the way, I will show you the end cumulative result over the last 6 months. Now, just that I was getting a feeling. One very important area where we improved a lot, and Daniel will present a bit more about it, and he worked on that intensely, was everything related to encoding and decoding of various parts of the code base. So this is just one example, improving a contract call by not encoding method name. I will not go into details, but the interesting thing is seeing numbers essentially. So this is how much the bytecode got reduced after this one single optimizations, and then you see here like 10%, 13%, 5%, in average like somewhere around 15. This was one of the huge improvements in this particular area of encoding and decoding. Or for example, this one, method selector on contracts, even bigger impact. On this particular one, I would love to point out deliberately this part where we got a regression actually. Having regression is let's say, always there when we are talking about the optimizations, and we are aware of that, and we analyze them. And for example, for this particular one, we know exactly why it is. It's explained in this PR. We know why it's not, let's say, relevant for real case scenarios, and we know that we're going to improve that one still as well. So one very important thing we are now working on, and Daniel will tell more about it, is so-called trivial encoded types. It's a concept related to encoding and decoding, which actually brings a lot of improvements in many different areas, in calling contracts, in returning values from contracts, in logging. So this is an area we are actively working on, and will continue also now in the first quarter of 2026. So this was a bit of an overview, let's say, of these three major areas. Maybe just for developers to get a feeling for the cumulative impact, like these were like just a couple of picks. The version 69.0 was the last version in June, and so this is the last version in December. So what I made here was a comparison of what was improved within a half a year, and the results are really good. Here is the summary, but just to give you an idea, out of 400 tests from which we were extracting data on 400, or out of 500 tests on 460, we got improvements in reducing the bytecode size, and in average for 50% in tests. That's a lot. On the other side, we have a very, very small number of regressions. And as said, these regressions, we know why they are there, and we're working on them. The matter of fact is, again, Daniel is actually, today we were discussing one of the regressions, cluster of regressions, which will also be improved soon. I will not now go into details. This document is available online.
Yeah.
So
And also, like, I would just like to point out, like, we even put out a tweet which contains the summary of everything. So I'm gonna be putting that dot in the description. If you want to check out, feel free to go ahead.
yeah, thanks for that one. I remember you summarized it also quite nicely.
Yeah.
Yeah. So this was the improvements in the output. I think this is what for the devs is the most important thing, like how performant is essentially the code which the compiler generates. On the other side, we had also one nice improvement on the compiler speed as well, but of the compilation speed as well. But it's coming from one interesting part. Essentially, the time needed to compile the standard library decreased a lot. So what you see here are the benchmarks from our language server. We have a couple of dedicated benchmarks on CI for the language server, and you can see some very, very nice improvements here. This one is particularly interesting. So for example, how much time it takes to open the workspace with all of our examples. And that time went down for almost 2 seconds on the CI. And how it happens, well, one of the features, language features, which we were working on called const generic, finally got enabled. And it turns out that it reduced a lot of code in the standard library. And Daniel will actually tell more about that. So at this point, I would love to hand over to him, so to go into a bit more details on trivial encoded types and also on const generics.
Yeah, I would like to actually point out that this is quite an interesting, and like it has a really like very huge impact, because let's say like when you improve compilation speed, it may or may not benefit projects that much, but when it optimize, or let's say have some performance improvement on the standard library, every project is going to use that essentially, and that optimization is going to benefit every project out there that is using or building on Swift basically. So that's like a really, really, I would say, big impact in all of them.
Yeah, definitely. Oh, maybe just one more general note. So this is like a short recap of the past 6 months, but we are continuing actually. So we have quite a few things in the pipeline where we expect to improve on both sides, especially and bytecode size. Right now, what we are working on right now, improving the compilation of the mesh expressions, which are heavily used, the way how we initialize objects like structs and arrays and similar. And as said, we're continuing with improvements in the encoding and decoding. Yeah.
Exciting. I'm excited like what it unlocks for the projects, and like how it benefits like the Sway compiler basically. Yeah.
Me
So
too. Yeah.
let me invite Daniel to the stage. Here
Yeah.
you go, Daniel.
Okay. Well, my idea here is to focus on two optimizations that Igor talked about. First, I'm probably going to focus a little bit more on the concept of trivially encodable and decodable types, because of all the optimizations that Igor talked about, this one's probably the most complex in the sense that it brings a new concept to the language. And the concept is quite easy. It's not nothing fancy or anything. But before we actually try to talk about this, I just want to remember to bring back a little bit the context where we are using this in the language. Because as Igor said, one of the aspects of this optimization, it spins around calling contracts. And this is pretty much what a Sway developer sees when he is calling a contract. But this is not what the compiler actually, how the compiler actually compiles this into. What the compiler does, it's kind of desugar this into this thing here, which which pretty much means that when you call a contract, we first encode its arguments and we decode its return type. I think that's summarizes what we're doing here. More details. We have this document here that explains very deeply what we're doing, but the important part is here. And one thing that we realized was that, well, encoding and decoding, they are not free in the sense that they increase binary size, of course, because it's we have to do a lot of things to encode and decode stuff. And of course, they also increase gas usage. And that was when we took the decision to, when we're choosing the encoding protocol, that was something that always bugged us a little bit because we encode and decode for a reason. That are the documents that I shown explains why. But we also don't want to impose too much cost on these things because this is not what the user wants to do. This is a bad cost. So what we realized was that, okay, encoding and decoding has this price that must be paid unless we have something. And this something is what we end up calling trivially encode and trivially decode. What happens is this protocol of encoding and decoding things can be free if the arguments are trivially encodable and the return type is trivially decodable. So, okay, but what exactly means being trivially encoded and decodable? And it's pretty easy. It's something that already exists, and it's very similar to the concept of zero copy deserialization. Of course, the encodable would be zero copy serialization, but they are very similar. And pretty much summarized to you don't need to do anything. So, but at the same time, this is very simple. It's also one has to answer. One has to ask why this. So why this was not there the first time? Why we're actually doing something in some case? And the issue is that unfortunately we cannot. Not all types are trivially encodable or decodable. So, for example, to understand what makes a type to be trivially encodable, let's look at a very simple example here. We have a tuple of a free U64. If we look at the runtime representation of these numbers, we see that they are just packed together here. So we have 1, 2, and 3 here, 8 bytes for each. Of course, they don't fit here on the screen, but that's pretty much how we represent them in memory. Yeah. And here is how we represent them when they are encoded. And if you pay attention, there is something that makes this type to be trivially encodable and decodable because their representation are the same. So we start to realize that a lot of types, they fall into this category and allow us to actually pretty much remove everything in terms of cost for encoding and decoding, and it becomes pretty much an OOP. It is not an OOP because we still have to do some stuff, but it's almost an OOP. And at the same time, one thing that we realized was that there are a lot of types that they look like they should be trivially encoded and decodable, but they are not for some reason. So I'm bringing here up also a very simple case that it is not trivially encoded and decoded. Maybe that will surprise, that can easily surprise developers. And the problem is that if you see the encoded representation here at the bottom, it's probably what you expect. You have just 1 byte here for one because it's only weight, and you have the 8 bytes here for the others. So it's pretty much what you expect. Maybe what you don't expect is the runtime representation. We have a bunch of zeros here in the middle, padding this struct, and that happens for some reasons that we still need fields of structs, or in this case, items, elements of tuples to be aligned. So the address needs to be a multiple of 8. So we may solve this in the future and make even more types trivially encodable and decodable. But at the present time, unfortunately, some types, they have padding in the middle. And one thing that we're also discussing is today it's 100% opaque to developers when a type has a padding or not. So you create a struct with U64, you realize that, well, I don't need that much memory. Maybe I'll just change to it to be more performant, and boom, you're actually less performant now. So we are actually thinking of ways for the compiler to actually help you or tell you that something is not trivially encodable. We are searching the solution for that, but that's pretty much
Mm-hmm.
summarize this concept.
Okay.
Uh, and another thing to actually show here, to be very, very simple in terms of the benefits, just to show, for example, the free U64, when compiled, they generate a binary of 136 bytes. Just changing the first argument from U64 to U8 actually increases to 208. So it's not obvious at all why it is happening. So again, we probably need to think on ways to improve that. So this concept here and this example showing the increase in binary size pretty much
Mm-hmm.
summarize all the benefits that we had on that PR that Igor showed about trivial encoded types.
Yeah.
Uh, and I
Yeah.
just want to, yeah.
I was just pointing out that it does increase the performance, like of the release and like building it out, but just increase the byte size a bit.
Yeah. We realized that in some projects, encoding and decoding can compromise almost 10% of the binary, sometimes
Mm-hmm.
even more, depend, of course, on a lot of things. But that's why we want to have a way for, at least for you to guarantee that at least the hot methods of your contract, they are trivially encoded and decodable. That may force you to change the data structure a little bit. That's why we're still trying to find the right balance here. But
Mm-hmm.
yeah, it's definitely something. It can have a real impact. And I just want to go really quickly here on how this is actually working, because the nicest thing about this is this concept. It is not needed to develop contracts or anything. You can completely ignore it, and everything's still going to work. But
Mm-hmm.
if you want to improve performance, there is no magic around this. Maybe there is a little bit of magic, but there is not a lot of magic around this. This pretty much summarizes to these new methods here on these traits, which uh, the compiler allow each type to tell if it is trivially encodable or trivially decodable. And
Mm-hmm.
this is, I copied this from the standard library. Of course, I did a little so some changes to fit here, but that's pretty much where the code is there. So we actually check if the code is trivially encoded or decodable, and we do whatever it's best here on the blocks of the VIF expression. But so we tried to take away all the magic from inside the compiler and bring back to the standard library, specifically to allow users to have the power to force if they want a non-trivial type to
Mm-hmm.
be trivial. And that boils down to this problem here, which is a concept that the problem is that uh, in my example, I use the U8. I could have used
Mm-hmm.
it. If you think about bool is also 1 byte,
Yeah.
and will cause the same problems that U8 is using. We're going to pad the tuple, etc. But bool has another problem that's called trap representations. And the problem is that Boolean, for example, it only accepts 0 and 1. Any other value would be invalid. And
Mm-hmm.
although when we generate code, we try to everything that's different from 1 to be treated as 1. We think that the serializing, the decoding a value 2 to a boolean is very dangerous. It's maybe not something that you want to do. So
Yeah.
uh, these types where they are only valid for a subset of their byte representations, they pose a very serious problems for trivially decodable types. Another example is enums. Maybe if you don't know how the runtime memory representation for enums, you probably surprise you, but when you define a enum, what happens is that its first 8 bytes here, they define the discriminant or each variant you have. And
Mm-hmm.
of course, because the discriminants are 8 bytes, I doubt that anyone is going to create an enum that fills all these values. So what
Yeah.
happens is that we cannot trivially decode an enum and still be certain that the discriminant points to a valid variant. That pretty much kills all enums. So enums are not trivially decodable by default,
Mm-hmm.
and that is one of the uh, possible changes that you need to do to your data structure if you want to have better performance. A solution for
Got it.
that, and that's why we actually decided to put this in the standard library to allow you to force types to be trivially decodable, is that with this code here, pretty much like what, 6, 7, 8 lines of code, I don't know, you can
Mm-hmm.
actually force any type to be trivially decodable if you deal with invalid values. So, for example, in terms of Boolean here, or you cast the boolean to another number and test if it's 0 or 1, or you don't care, or you just check
Mm-hmm.
if it's true. I don't know if you are certain that invalid bit representation doesn't break anything, you can actually force this yourself. For enums, it's actually easier because when you match enum, we guarantee that invalid representation is going to revert,
Mm-hmm.
but well, you can still do it whatever you want manually for this case. So that's one of the reasons that we decided to go this way. I
Yeah,
think.
so like for enum it is not supported, like it is not enabled by default, but developer can forcefully enable it.
Yeah, we are
Got
thinking
it.
if we're going to ship something similar to this or not. We're still trying again. We're still trying to find the right balance for everything here. The
Mm-hmm.
issue is that uh, it's if you force a type that has track representations, it is a danger, and it can open to attacks if you don't know what you're doing. So
Mm-hmm.
we're still not certain what we're going to ship, but it is something that's doable, and as you see here, it's very easy to do.
Yeah, agreed.
Okay, that's pretty much summarizes this concept. It's a new concept. Again, we're still trying to
Mm-hmm.
find all the right balances here, but I think that's it. If someone wants to
Maybe
make any
just
questions, further.
one thing, Daniel, you mentioned it already, but I just want to come back to that. Essentially, how easy is to slip from something which is actually decodable and encodable trivially to something which is not unintentionally. And there we were discussing also like a language kind of a support that the developers can put the guard against it, or at least be warned about it. So
Yeah.
this is also something which will come. I would say to the whole topic, improving what we have right now, just with this concept, already brings a huge improvements. And what Daniel explained is that we still have even a room for going into, okay, developers who wants to opt in into even more performance will be able to do that as well.
Mm-hmm.
And on top of that, we very likely put this, that even developer can put the guard around this. So expect in the future quite some development in this area.
Interesting. Like that leaves developer with quite a bit of power, I would say.
Yeah, yeah. As Igor said, there are a lot of things that you do expecting to improve performance that can actually kill in terms of encoding and decoding. Like I
Yeah.
said, if you use a U8 or a Boolean, if you use enums, if you use data structures like VAC, even order of fields can actually make a type not trivially decodable, for example. So yeah, we need to improve on that in terms of being more clear when this happens. We try to find the right balance, but definitely something is going to happen in this area.
Got it. Yeah, makes sense. That's like quite a lot of optimizations, I would say, especially the one that Ego compare from where we were 6 months back. and the way where we are now. So I would say like that's mm, quite a bit like quite a big optimizations in terms of like performance and like experience overall. So
Yeah.
yeah, I have just like one last question for the devs ahead, like what they can expect for the 2026. Like, if you can share a bit of roadmap, what this what the like the next releases are gonna look like, or like what's on your roadmap, like even anything like that you have in mind.
Yes, yeah. To that, so first of all, for the first quarter, we will definitely continue with the topic of optimization. So in terms of the language feature, we expect like less like new language features. If you're not talking about this, for example, what Daniel says, which it comes also as a language feature, but the
Yeah.
huge focus will be on the optimizations. Then on top of that, if you remember the whole infrastructure we improved on troubleshooting, like the ABI errors and ABI
Mm.
backtracing and everything else. That's there, but we still have to roll it out. So that's something developers can expect, that the full
Mm-hmm.
rollout in the standard library, and also, of course, in all the libraries which Fuel is developing. This is going to
Yeah.
be a huge change, and we will continue with the language features. Foremost, the references are one which are still there for quite some time, open.
Mm-hmm.
So we will continue with that part, which will also have impact on the performance as well. And there is another one, like long-lasting feature, which is the new storage, like so-called storage 3.0, with improvements around that. This is also something we expect to tackle this year. So let's say
Mm-hmm.
in terms of the bigger language features, I would single out these two. Yeah,
That sounds amazing. I'm excited for it.
yeah.
uh
The
cool.
language is developed quite well. Yeah, I'm happy with it.
Yeah, yeah. Agreed. So yeah, that brings us to the end of the session. Thanks, Igor. Thanks, Daniel, for joining us. Uh, that were like quite a big of updates and like really nice work. So yeah, I would like to sign off the session. I forgot to wish you all happy New Year. Like I hope you had an amazing holidays, and I wish a great year ahead. So see you in the next call next month. Until then, bye bye.
Yeah. Thanks, Nazik. Thanks for having us. Bye.
Thank you guys.
All right.